Okay, so this is question 14 for the Friction U Texas, and you have the 1400 kilogram car, which is weirdly drawn. There you go, there's the wheels. And it's moving at 18.1 meters per second, which is velocity, on a horizontal road that is wet, so take that into account. And for my values, I have the static coefficient is 0.192 and the kinetic coefficient is 0.1344. I'm assuming yours is going to be different, so also be sure you're careful with that. And you're finding the shortest stopping distance for the car, and your answer is going to be in meters. So I provided you with a formula up at the top right corner in green, and it's MA, which is the net force, equals mu mg, which is mu times the natural force, and that equals the force of friction. And because m is on both sides, m is going to cancel out each other, so it's going to be A equals mu g. Sorry about all the noise in the background. So you have acceleration equals mu times g, because the masses cancel out each other. For this, you're going to be using the static coefficient because you're finding the shortest stopping distance. You're going to be using the static coefficient, and so in the problem it gives you the gravity. It has an acceleration of negative 9.8 as usual, and so you can use that to figure out your acceleration. Once you find out your acceleration, you can plug it into the VI squared equals VF squared plus 2AD equation, and that way you can find your distance. Hope this video helped. Okay, so this is question 15, which is very similar to question 14, except they changed up the values a little bit. In my question, you have a 1700 kilogram car moving at 13.9 meters per second on a horizontal road, which is again wet, and the static coefficient is given here, 0.398, and the kinetic friction is 0.2786, and of course your values may be slightly different than mine, so be careful with that. And you are using the same equation up here, and you're trying to find the highest possible deceleration. So this time you're finding the acceleration of the car. Again, the masses cancel each other out, which leaves accelerations equals mu times gravity. And again, you're going to be using the static coefficient for mu, and gravity is equal to negative 9.8, and that will give you your acceleration. Hope that helps.